Today, we will explore the syntax and examples of for loops in programming. This session aims to provide a comprehensive understanding of how for loops function and their practical applications in coding. The system.out.print command in Java allows you to print output without moving to a new line, unlike system.out.println. This is useful for creating continuous lines of text. For example, combining print and println can produce seamless output on the console. Repetition in code can be streamlined using for loops. Instead of writing redundant lines, a for loop can execute a task multiple times efficiently. This reduces code length and enhances readability, as demonstrated in the Java example provided. A for loop in Java executes a block of code repeatedly until a specified condition is met. The loop consists of initialization, a test condition, and an update statement. Understanding these components is crucial for effectively utilizing for loops in programming. The simplest use of a for loop is iterating over integers within a range. For instance, a loop can calculate squares of numbers from 1 to 6, demonstrating how for loops can automate repetitive calculations efficiently. This flow diagram illustrates the execution process of a for loop. It begins with initialization, checks the test condition, executes the loop body if true, updates the counter, and repeats until the condition is false, ensuring a structured flow of operations. Let's walk through a for loop example. Starting with an initial value, the loop checks a condition, executes the body if true, updates the counter, and repeats. This step-by-step process highlights the loop's functionality and control flow. Here's another for loop example that prints a pattern. The loop iterates 3 times, printing specific characters to form a visual design. This demonstrates how for loops can be used creatively for text-based graphics. A single line for loop can omit braces if it contains only one statement. However, this can lead to errors if additional lines are mistakenly thought to be inside the loop. Proper use of braces ensures clarity and prevents logical errors. Variations in for loops allow for different initial and final values. For example, a loop can start at -3 and end at 2, demonstrating flexibility in loop design. Adjusting the loop body can achieve the same output with different parameters. Complex for loops can be syntactically correct but hard to understand. It's essential to write loops that are easy to read and maintain. Simplifying expressions and using clear logic enhances code readability and reduces errors. A for loop can count downwards by using a decrement operator. This requires changing the test condition to greater than equals instead of less than equals. Such loops are useful for countdowns or reverse iterations, as shown in the example with a countdown to blast off. Degenerate loops either execute 0 times or infinitely. A loop with a false initial condition won't run, while one with a never-failing test runs endlessly. Understanding these scenarios helps prevent logical errors in loop design. For loop exercises challenge you to produce specific outputs, such as sequences or repeated characters. These exercises demonstrate the power and versatility of loops in automating repetitive tasks and generating complex patterns efficiently.